On RT4-2, we're going to use the law of cosines. So most of you know that in a right triangle, c squared is a squared plus b squared. But those ancient Greeks, again, had a bunch of free time on their hands, and they were like, well, what happens if it's not a right triangle? So if it's an acute triangle, c squared has to be less than a squared plus b squared. And if it's an obtuse triangle, c squared has to be greater than a squared plus b squared. And they were like, I wonder what we can do to make it work in all three. And so they figured out that it has to be c squared equals a squared plus b squared minus something. Okay? Or sometimes it's plus something. And they did a whole bunch of playing around, and honestly, I'm not entirely sure how they figured it out, but they figured out that what you are subtracting is 2 times AB times the cosine of C. So the law of cosine says for any triangle with sides ABC and angles ABC, where the angles are opposite the sides, and this should be a lowercase c, c squared equals a squared plus b squared minus 2 times a times b times the cosine of angle C. That's a lot. We're going to practice using it. So I'm asked to find x. This is the side I'm looking for. This is the angle I have. Those have to be C. Everything else can be either A or B. Doesn't matter. So I'm going to start with my formula. My side c squared equals my sides a squared plus b squared minus 2 times a times b times the cosine of angle C. And now I'm plugging everything in. X has to be my side c squared. It doesn't matter which side is A and which side is B, as long as I use both of them. Minus 2. Again, it does not matter which side is A and which side is B, times the cosine of 36 degrees. And I'm going to plug all of that into my calculator. So I get 45 squared plus 52 squared minus 2 times 45 times 52 times the cosine of 36 degrees. Whoa. And I get 942 and some change. I'm going to take that answer, I'm going to copy it, square root, paste it, right, because x was, I think, 943.08 something, something, something. When I square root both sides, I get x is 30.7. And notice, friends, I'm only rounding at the very, very end. Okay, so I might write down just part of what I have on my calculator to keep track of my work, but I'm going to use that entire number when I'm doing my next step. Otherwise, I get an internal rounding error. All right, we're asked to find x again. Again, I'm going to start with my formula. C squared equals a squared plus b squared minus 2 times a times b times the cosine of C. This is the side I'm looking for, and this is the angle I have. Those are opposite each other, so they have to go in for C. So I get x squared equals, and it does not matter which one is A and which one is B, 23 squared plus 28 squared minus 2 times 23 times 28 times the cosine of 82 degrees. And I'm plugging that entire thing into my calculator to find what x squared equals. So 23 squared plus 28 squared minus 2 times 23 times 28 times the cosine of 82 degrees. And I get 1,133 33.745, and I'm only going to write that much, but I'm going to use the entire thing. So I'm taking that answer, I'm going to copy it, and to get x, I need to take the square root of each side. And x is 33.7. On this next example, I'm asked to find this angle Q. 45 is opposite the angle I'm looking for, so that one has to go in for C. So I'm still going to start with my formula. C squared equals A squared plus B squared minus 2AB times the cosine of C. 45 is opposite the angle I'm looking for, so that one has to go in for my side, C squared. And that has to equal 51 squared plus 42 squared minus 2 times 51 times 42 times the cosine of Q. And now I'm plugging all of this into my calculator to clean it up. So I'm going to have 45 squared. It's 2025. And that will equal 51 squared plus 1,764 minus 2 times 51 times 42, 4,284 times the cosine of Q. And I'm going to pause here just for a second and we're going to think. Some of you want to combine all of this right now. And you want to type in 2,601 plus 1,764 minus 4,284 and get some number cosine Q. But that doesn't work because this has a variable, cosine of Q, and these two don't. So they are not like terms. So I can combine my like terms by adding these, but I can't add this piece on. Okay, so I'm going to do that. So I'm going to do 2,601 plus 1,764. Clean up my work just a little bit. So I have 2,025 equals 4,365 minus 4,284 times the cosine of Q. If I were solving this with just normal algebra and I had 2,025 equals 4,365 minus 4,284x, most of you would know, hey, I need to subtract this from both sides. The same thing happens when I have cosine of Q for my variable. Okay, I'm still treating it like a variable because it is one. So I'm doing 2025 minus 4,365, and I get negative 2,340, and some of you are really worried about that negative, and you don't need to be. My next step then is going to be to divide both sides by negative 4,284. And I get 0.5462 and some change equals the cosine of Q. When I want to undo cosine but leave Q, I need to do the inverse cosine. So I'm going to take that answer, I'm going to copy the entire thing, and Q will equal the inverse cosine of 0.5462, and even though I only wrote 4 digits, I'm going to use what I copied from my calculator, use the entire thing, so the inverse cosine, and I'll paste that, and Q must be 56.9 degrees. Again, we're asked to find the angle T. So I'm starting with my formula. C squared equals A squared plus B squared minus 2AB times the cosine of C. I'm looking for angle T. So the side across from it has to go in for C. So 51 goes in for C. A and B can be either one. And now I'm just cleaning things up. So 51 squared is 2,601 plus 70 squared plus equals 70 squared plus 62 squared minus 2 times 70 is 140. 62 is 8,680 times the cosine of T. These two pieces do not have a variable attached, so I can go ahead and clean them up. This piece has a variable attached, so it's not like the other two. So my next line will look like 2,601 equals 4,900 plus 3,844. 8,744 minus 8,680 cosine of T. I'm going to subtract 8,744 from both sides and get negative 6,143 equals negative 8,680 cosine of T. When I divide by negative 8,680, I get this big scary looking decimal. I'm going to write down just 4 digits of it, but I'm going to use the entire thing. To get rid of cosine but leave the T behind, I have to do the inverse cosine. So I have inverse cosine, that decimal equals T. And I'm going to copy the entire thing. Even though I only wrote out 4 digits, I'm using the entire thing so I don't get a rounding error. And T has to equal 44.95 degrees.